The lesson today we're going to talk about is how to evaluate or reduce square roots. So evaluating square roots, what we're doing is we're trying to figure out what the actual numerical value is. Some of them will be perfect squares, some will not. So if it's not a perfect square, we have to be able to reduce it and still have an exact value. So we'll start with a couple of examples. So the first example is going to be the square root of 16. Well, the square root means what number multiplied by itself would give me the number inside. So the square root of 16, how can I get 16? Well, I can do 4 times 4. So that becomes just the answer of 4. Whereas the square root of 36, what number can I multiply by itself to get 36? Well, 6 times 6. Now the other one is the square root of 24. What number can I multiply by itself to get 24? Well, there is no number you can multiply by itself to get 24 that's a nice integer. So what we do is we want to try to reduce this square root of 24. We know that the decimal value is going to be approximately 4.9, and I'm guessing that because the square root of 24 is really close to the square root of 25. And the square root of 25 is 5, so this is just a little bit number. This is just an estimate, 4.9. This is not the answer that I'm looking for. What I want to do is I want to take the square root of 24 and I want to reduce it to its simplest form but not have an approximation, 4.9. So what I do is I take this and I look for two numbers that are the exact same that are factors of 24. So what I do is I take 24 and I think about ways I can multiply to get 24. There's lots of ways to multiply to get 24. I'm just going to use this one, 4 times 6. Then what you do is you look, is 4 and 6 the same number? No, they're not. So what you do is you go through and you do it again. We'll take 4. 4 can break down to 2 times 2. 6 can break down to 2 times 3. Well, notice 2 times 2 is 4. 2 times 3 is 6. And if I multiply those together, I get all of this. If you multiply 2 times 2 times 2 times 3 together, you're going to end up with 24. So this is the same thing as what I started with. Now we're talking about square roots. So we're looking for two numbers that are the exact same. So I circle those. What happens is one of those comes out of the square root and one of those gets crossed off. Square roots mean two numbers that are the exact same. One of them comes out, one of them gets crossed off. So the answer that we're going to look for is 2 square root of 6. Where did the 6 come from? 2 times 3. Those are two numbers. They're not the same thing, so they have to stay inside the square root. They can't come out. So let's do the same thing for the square root of 12. 12 is not a perfect square, so I can break that down to 4 times 3. Well, those are not the same number, so I keep breaking them down. 4 and 4 is 2 times 2. 3 can't break down other than 3 and 1, so we get this. There's two numbers. One of them comes out, one of them gets crossed off, and you get the answer 2 square root of 3. That's what we're going to do. We're going to get rid of the square root if it's a perfect square, or we're going to reduce it down to an exact value. So what do we do in this? Square root of 16 plus 9. Order of operations says to do what's inside the square root first, which becomes the square root of 25. Then the square root of 25 just becomes the number 5. Square root of 14 minus 5. 14 minus 5 is 9, so that becomes the square root of 9, which becomes just 3. Square root of 24 minus 8, subtract those, that becomes the square root of 16. The square root of 16 is 4. Then we go to the next one. 12 plus 20 is the square root of 32. This is not a perfect square, so then what we want to do is we want to try to break this down. 32, I can rewrite that as 8 times 4. Well, 8 and 4 are not perfect squares, so I can rewrite this as 2 times 4, and then 4 can be written as 2 times 2. I do have a couple pairs, but this 4 can break down further, so what I do is I go a little bit further. This 2 just drops down. This 4 becomes 2 times 2. This 2, these 2's just drop down. So notice we have all these 2's. Well, here's a pair of 2's, and here's a pair of 2's. One of these jumps out, one crosses off. One of these jumps out, one of these crosses off. So we had two 2's that came outside. What do we do with those two? We multiply them together. This 2 doesn't have anything to pair with to come out, so it has to stay inside, and we get the answer of 4 square root of 2. And that's the answer that I would be looking for. Okay? So let's go to this one. Reduce the radicals. Square root of 500. Well, the square root of 500 becomes 5 times 100, or 5 times 100, Then I can break that down to 5 times 10 times 10. And notice how there's already a pair of numbers here. These two numbers can be circled. Once you get a pair, circle them. One of them comes out, one gets crossed off, and your answer becomes 10 square root of 5. The 5 can't break down any further, so that's where my answer is. Square root of 75. I can break that down as 3 and 25. 3 and 25. 3 is a prime number, so it stays the same, but 25 can break down to 5 times 5. There's a pair of numbers. One comes out, one gets crossed off, and you get 5 square root of 3. Okay? Now these two, C and D, are a little different. We have two radicals that are being multiplied together. If I look up at this rule up here, notice how we have two radicals that are being multiplied together. That's the same thing as one radical with the two numbers inside of it. So I can rewrite this as 6x times 3x. 6x times 3x. Now notice I did not write them as 18x squared. The reason why is because I'm going to break them down anyways. So 6 and 3, well 6 can break down to 2 times 3. Then there's the x. Then 3 can't break down, so I get this. So now what I'm doing is I'm looking for numbers that are the same. Notice this 3 and this 3 are the same. Notice this x and this x are the same. There's my pair. 1, 3 comes out, 1 gets crossed off. 1x comes out, 1x gets crossed off, and you get the answer 3x on the outside square root of 2. And that is your final answer. Okay. Now, for the next one, I'm going to do the same thing. I'm going to move it down here. I'm going to start down here so I get some room. So again, I take this and rewrite it as 5x times 10x. And then 5x and 10x are not like, so I need to break them down. 5x becomes 5x. 10x becomes 2x, or 2 times 5x. Notice there's a 5 and there's a 5. Here's an x, here's an x. One of the 5's comes out, one of them crosses off. One of the x's comes out, the other one crosses off. So what's on the outside? 5x. What's left on the inside? A 2. And that would be your final answer. Okay? Same thing here. Square root of 1 over 25. Well, if I look up at the top of the rule, this should say square root of a over b is equal to the square root of a divided by the square root of b. So I can break this up as the square root of 1 over the square root of 25. Well, the square root of 1, well, 1 times 1 is 1. Square root of 25 is 5, so the answer is 1/5. So if I do this, the square root of 36 over 25, I can break that up as the square root of 36 divided by the square root of 25. Well, the square root of 36 is 6. The square root of 25 is 5. There's my answer. This one here, 48x to the third over square root of 6x. Well, on this one, I can rewrite it, go from 2 radicals down to 1 radical. Sometimes it'll be easier to reduce this first. Sometimes it's easier to write it as 1. In this case, I would go ahead and write it as 1 radical, because what happens is you get 48x to the third over 6x. 48 divided by 6 is 8. X squared divided by x just becomes x squared. Notice by doing this, the fraction goes away. Sometimes that'll happen. And then you reduce this. 8 becomes 2 times 2 times 2, and x becomes x and x. I have a pair of 2's, and I have a pair of x's. 1, 2 comes out, 1 crosses off. 1x comes out, 1x crosses off, and I get 2x on the outside and a single 2 on the inside. D's the same way. Okay, rewrite it as 1, so that becomes 150x to the third over 2x. Divide, that becomes 75x squared, 150 divided by 2, and then that becomes 3 times 25 times x. Well, the 3 becomes 3 times 5 times 5 times x. There's a pair, there's a pair. 1 comes out, 1 crosses off. 1 comes out, 1 crosses off, and you get the answer, 5x square root of 3. And that's your final answer.